Hello everyone, I am Saranya, working as a assistant professor from SNS College of Engineering. Today's my topic is a multi-layer network and backpropagation. The first topic is a multi-layer network. A multi-layer network is often to refer to as a multi-layer perceptrons, which are the classes of the artificial neural networks. It consists of multiple layers of interconnected nodes, that means neurons. Here that these networks are fully connected to the meaning of each connected to meaning each neurons in a one layer is connected to every neurons in the next layer. These are used to the model complex and nonlinear relationship in a data to for all tasks like the classification and regression and more. Then it is a consist of a input layer, more than one or more hidden layers and an output layers. The each layer is consist of the neurons that process the information and pass it to be a next layer. The hidden layer enabled the network to learn the complex and nonlinear relationship between the input and outputs. The next one is a structure of multi-layer networks. It is the consist of the five layers in the multi-layer networks. The first one is a input layer, the second one is a hidden layer, and third one is an output layer, and fourth one is the weights and biases, and fifth one is the activation functions. The first one is the input layer. The input layer is the to receive the input features, that means a pixel values for the image or numerical data. Then hidden layer is the one or more layers of neurons that process of input through the weighted connections, it bases and activation of functions, for example of sigmoid and tanh. This layer is the capture the hierarchical features of the platform. Then third one is an output layer. The output layer is to find the final output. It is in such as a probabilities for the classifications or continuous values for the regression. Then fourth one is the weights and biases. It is consist of parameters that transform the input as the pass the truth of the network. The final one is an activation function. In this function, to introduce the non-linearity, enabling the network to solve the complex problems to the common function problems, which it is the common functions are included in the sigmoid, ReLU and tanh. A sigmoid is the sigma of x equal to 1 divided by 1 plus e power minus x. Then ReLU is f of x equal to maximum of 0 comma and x. Then tanh equal to tanh of x equal to e power x minus e power minus x divided by e power x plus e power minus x. The next one is an backpropagation. A backpropagation is a supervised learning algorithm. It is used to train the multi-layer networks by it is an adjusting the weights of the connections to between the neurons to minimize the difference between the network's output and the desired output. Uh, uh, which it is involved in the two main cases. The first one is a forward pass, second one is a backward pass. The forward pass is the input data of lead through the network in layer by layer to generate the predictions. Then backward pass is the backpropagation, which is the error between the predicted and the actual output is calculated and propagated in the backward through the network. When the during the backward pass is the algorithm to calculate the gradient of the error function uh, with respect to the weight and bias. These gradients to indicate the how much each weights and bias should be adjusted to the minimize the error. Here that the weight and biases are then to upload using the optimization of algorithm to like a gradient of descent. In this process is to repeated the literally over the multiple training examples under the network performance reach in the satisfying the levels. Then backpropagation, how to work the backpropagation? It is worked into the forward pass and backward pass and compute loss and update the parameters to, and then final one is repeated. Here that the forward pass and backward pass is the already discussed in about the previous slide. Then the next we have to discuss into the compute the loss. It is to calculate the loss of L by to comparing the predicted output to the rule to true target using the loss functions. Then the update parameter is the adjust the weight and biases using the Gaussian descent. Then repeat mode is the to iterate over multiple layers and until the loss coverage or the stopping the criterion to meet. The next one is an advantages of backpropagation and challenges with the backpropagation. First, we have to discuss into advantages of backpropagation. The first one is an easy of implementation, and second one is in simplicity and flexibility, and third one is an efficiency, and fourth one is a generalization, and fifth one is a scalability. These are the advantages of backpropagation. Then challenges is the vanishing the guardian problem and exploding guardians, and overfitting is the challenges with the backpropagations. Thank you.